Tonight's video is on section 3.1, Extrema on the interval. The homework that goes along with this from 3.1 is 1 through 18. We'll be working on this in class tomorrow and Tuesday. It'll be due Thursday in class. Relative extrema. These occur only at turning points. That is, when a graph changes from increasing to decreasing, or vice versa, from a decreasing to an increasing interval. A definition of a critical number. Let f be defined at x equals c. In other words, f of c exists. Number 1, if f prime of c equals 0, remember that is the slope of the tangent line to the graph of f at c is 0, in other words, a horizontal tangent line. Or 2, if f is not differentiable at x equals c. Where are the two places that it's not differentiable? I sketched out a picture. Right here at this c value, or at this c value when there's a vertical asymptote. That's the tangent line. Or here. Then c is a critical number of f. So there's two ways of getting critical numbers. These critical numbers c's on f. How can I get them? If f prime of c equals 0, so at that 2, the slope of the tangent line to the graph of f is equal to 0. In other words, it's a horizontal tangent line. Or if at c, f is not differentiable there, which would be here or here. Those would be called critical numbers. So now I can expand relative extrema. They occur only at critical numbers. If f has a relative minimum or a relative maximum at x equals c, then c is a critical number of f. And you'll see that in a moment. Here's a note. To find critical numbers algebraically, take the first derivative, set it equal to 0, and find out which values make that true. Or determine where f prime of c is undefined. So let's go through this pictorially. Here's a graph of f. So I denoted the highs and the lows. That's a relative max, min, max, and a min. That goes from increasing to decreasing, decreasing to increasing, increasing to decreasing, decreasing to increasing. And so I found the c values or the x values for these relative mins and max. So these are the critical numbers of f. So these are the slope of the tangent line. This is where the slope of the tangent line would be equal to 0. Here, and here, and here, and here. F prime of C4 is equal to 0. F prime of C3 is equal to 0, because the slope of the tangent line is equal to 0 at C3. So these are called critical numbers of f. Next is absolute, not relative, absolute maxima or absolute minima. The absolute highest or the absolute lowest y value of a graph on a particular interval. Let's look at a pictorial representation of this. I have a graph of f. I'm going to go ahead and use the interval, a closed interval from a to b, which means I can also use a and b. I'm using interval notation there. So when I look at these values, at this one here, and then the lowest would be here. Within this interval here, f of b, which is a y, is the absolute maximum. That's the absolute maximum or highest y value within this closed interval from a to b. And f of c is the absolute minimum. It's the lowest y value in this interval from a to b. You can't go any lower and you can't go any higher within this closed interval. So that's your absolute max. This is your absolute min. It is found here at C1. It is found here at B. That's it for this evening. Thank you.